Hi, this is Ms. Hess again, and this is the second part of the stoichiometry lab video. And what I just showed you in the last lab, and where it kind of cut me off and ended, was how to find the different masses that are part of problem number 1. And what I wanted to do was show you an example of a stoichiometry problem, which is 2A, where we're looking at solution 1, which is 2 grams of sodium chloride, the salt, that's in a water solution, and we need to find out how many grams of silver nitrate must be added to the solution to complete the reaction of sodium chloride according to the reaction above. So we want to be able to add some silver nitrate in here and have it react completely, which is over here. So what I'm going to do is do a stoichiometry problem. We were given the reaction prior to starting this, and we can see that it's already balanced. There's nothing that we need to do. First thing you always want to do is check to see if this is balanced. The other thing that you're going to need in this particular calculation is to look at this chart. We're starting off with grams of substance, 2 grams of sodium chloride. So that's going to be the first thing we want to type in. And this is just equation editor with Word. So we're going to have, and if you ever want to find it, it's right underneath here, 2 grams of NaCl. Alright, the next thing we're going to need to do is we're going to need to multiply it. I'm just going to use parentheses for the things that I need to multiply, and we're going to use a ratio. And what we need to do is go back to our chart and see that when we have a grams of substance, we have to put it into moles. So we have to take the molecular mass and figure out what the ratio is to 1 mole. So in this particular problem, we need 1 mole of sodium chloride is equal to, and this is something that we should have calculated in our pre-lab. So in this case is equal to 58.439 grams of sodium chloride. I'll put parentheses around that. The next thing that we need to do when we look at our chart is, now that we've multiplied it by our molar mass so we can change grams into moles of substance A, we're going to have to move it to substance B, so we're going to have to find out that molar ratio. In this particular problem, we see that there's no numbers in front of our substances, so our molar ratio is going to be 1 to 1. So 1 mole of AgNO3 over 1 mole of NaCl. Now, if you notice that these are in a position where I can cross out the NaCl. 1 mole of NaCl here, 1 mole of NaCl there. Those will cross out using division, and now I've changed the equation over into the sodium, or into the silver nitrate. The next thing I'm going to do, if I look at my chart, now that I've changed it into this B substance, is I need to find the grams of substance B. So I'm going to have to take the molecular mass and divide it by 1 mole. So in this particular experiment, we've got 1 mole, and notice I'm putting the first one on the bottom. And my grams for 1 molecular mass, or 1 molar in grams of silver nitrate, is 169.87, and I calculated this. Yours might be a little bit different than mine depending on which periodic table you're using. But this is your equation. You're going to go ahead and do all the multiplication and division here, and your answer is going to be the amount of grams that you need to use. You're going to go back to your lab. You are going to go back to your workbench. You're going to add that particular amount, and then you want to double check to make sure all the solid is used. And that's how you do this portion of